ladies and gentlemen, welcome back for another round. This is Mr. Doolin. I thank you for tuning in. Today what we're going to do is we're going to take a look at some mental math. And so what this means is this is the time of year that we've got a test coming up where we are not going to be able to use a calculator, but we are going to be asked to do lots of calculations. And so you got to know how to do this stuff in your head. And so there's little tricks that I'm going to show you here today to make this a little bit easier, all right? So first things first, and I want you to write this next statement really big in your journal so that you know your chill book. Get it in there. First things first, review your multiplication tables, 1 through 12. Hey, what's 11 times 10? What's 12 times 4? What's 6 times 3? What's 5 times 8? Like, you got to know all that stuff right off the top of your head, ladies and gentlemen. 1 through 12, multiplication tables. Get it done. Go back. It'll just take a second if you go back and look through them to get them back fresh into your mind. Next thing, what we're going to do, and I'm going to write this one, I'm going to write it as fractions. Yay for fractions. Learn to love them. Learn to love them. If you can start working these problems as fractions and keeping them in fractions rather than needing a decimal place, which is what we use when we put them in calculators, but if you can leave them as fractions, your life will be an amazingly simple process while we're going through these tests and through these mental math exercises, all right? So I'm about to do a magic trick. You ready? Alakazam and pow! All right, ladies and gentlemen, there you go. Man, that was a good magic trick. So all of my fractions just magically popped on there because I love fractions, ladies and gentlemen. But in all seriousness, these are the fractions that you're just going to have to know. I mean, do you have? No, you won't have to know them. I guess technically not. No, you don't have to know them. If you don't want to know them, don't know them. But please don't expect and get frustrated when you start struggling with doing the mental portion of this math and you're doing your math in your head a little bit slower. It'll help if you have these decimals down. You'll see a lot of these numbers and be able to convert back and forth from the decimal form to the fraction form because it's a lot easier to work with these in fraction form when we're doing multiplication in our head. All right? And so here's an example. So let's say I've got 0.75 times 0.5, and what does that equal? Well, I don't have a calculator sitting in front of me, and so what do I do with this? Well, I know 0.75 is actually 3/4. I know 0.5 is 1/2, and I can do this. Remember, multiplying fractions, I just multiply tops times tops, bottoms times bottoms, so this actually equals 3/8, and then if I want to report that in decimal form, I see that that's 0.375, because 3/8 is one of the fractions that I need to know how to convert from fraction to decimal form. All right? And so not anything crazy. Could I have done that longhand? Sure, I could have done that longhand, but it takes time, right? I can see in my head 3/4 times 1/2 equals 3/8, and that's 3/8 is 0.375, and I don't have to write it down. I just get it done faster, right? And time is of the essence here. Another example for this is what if I did 0.375, right? A lot of y'all are seeing that as 3/8 times 0.8. Well, this becomes a little bit difficult. If you're going to do this longhand, now I've got 3 decimal places to multiply out. Well, if I see this as 3/8 times 4/5, then I can just multiply it out. Simplify that one as 1 and 2, and this is going to equal 3/10. Well, I know 3/10. Those are always just decimal forms, so that's 0.3. And again, I didn't have to do anything. I do it really quickly, right? And I can just go boom, 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 and go through this. Now, the other thing that I'll leave you with here, ladies and gentlemen, and just kind of a little example, what happens when I'm dividing? So what happens if I take something like 0.375 divided by 0.8? Well, what that actually equals out here is 3/8 divided by 4/5. So how do we treat fractions when we divide, right? The old saying that I always remember is don't ask why, flip it, and then multiply. So what I'll do is I'll do 3/8 times 5/4. Notice the bottom one always gets flipped when I'm dividing by, gets flipped. Don't ask why, flip it, and then multiply. And then I end up with 15/30 seconds. Well, I don't memorize 15/30 seconds. I have no idea what that is, but I know that's approximately a half, which is approximately 0.5, right? I know it's a little bit less than half. I'd expect the answer to be a little bit less than 0.5, but I'm in the ballpark there, and I didn't have to do anything and sweat anything, right? That looks funky to me. I don't know what that is, but that looks kind of funky to me, just because it is what it is. Now, something you could do here is see that as, I could round this up as well. I could see that as 0.4 over 0.8 and run this as 0.5 or a half, and I end up with that as the same spot anyways. All right? Okay, so there we are. Fractions, ladies and gentlemen. Learn to love them. All right, so now what we're going to do is we're going to take a look at the other part of what's going to make your life considerably easier over the next few months is scientific notation. And how do we work with scientific notation? Really, in math, this is just how you treat exponents is all that we're going to be doing. So there's two different situations that we'll run into. The first one is when we multiply these exponents, and the second one is what do we do when we divide these exponents? All right? Well, if we're multiplying, all you do is you add the exponents. Nothing crazy there. When you're dividing, we subtract our exponents. Now, a lot of times students will ask me this, well, Mr. Doolin, what do we do if we're adding and subtracting? Well, if you're adding and subtracting, you actually have to make the exponents exactly the same. And as soon as you make them exactly the same, then you can just add or subtract the numbers that are in front of the exponents. All right? And I'm talking about powers of 10 here in scientific notation. So if you're going to add or subtract, the exponents actually have to be exactly the same to do that. All right? And then it's just an addition-subtraction problem, and you can do that in your head. All right? But if I'm multiplying or dividing, multiplication is going to be adding exponents. Dividing is going to be subtracting exponents. So I'll do a couple of examples here with you. Let's say I've got 4.2 times 10 to the 25th, and I want to know if I divide that by Avogadro's number, which is 6.02, I'll make it consistent here, times 10 to the 23rd. Well, I'm dividing here, so I'm going to subtract my exponents. I know this is going to be times 10 to the second, because 25 minus 23 is equal to 2. And then I'm looking right here, and wow, look at that. That's 4/6. Whoops. That's 4/6, which simplifies out to 2/3. Well, I know what 2/3 is. That's 0.67 times 10 to the second. Well, I don't have to leave that in scientific notation. That's just 67, folks. Move the decimal 2 places, and bam, right? So the answer is 67 or somewhere around 67. The other example I'll give you, and this will be something that we run into relatively often, is let's say I've got something like 25 moles. Actually, I don't want to make that 25. Let's make that 45. 45 moles of a substance. I want to know how many particles are there. Well, this means I'm going to multiply by Avogadro's number, right? And so what do? Well, the whole multiplication is I want to add exponents, but notice 45 doesn't have any exponents. So what the heck? What do? Well, what I'm going to do in this particular case is I'm going to turn this one into scientific notation. So times 10 to the first, that tells me to move it one place over there, and that's 6 times 6.02 E23. Now I've got both of them into exponent form, so notice I'm going to do this. That's going to be times 10 to the 24th, because 1 plus 23, and then 4 times 6 is 24. And again, notice I just dropped the 4.5. I mean, I could do that. That's going to technically be, what is that, 4.7, or the 0.5 times 6 is 3, right? So add that to the 24, and I get 27 times 10 to the 24th. Now remember, when I'm doing scientific notation, I want my number in front to be between 1 and 10, or 1 and 9, really. And so I don't want to leave it as that. And so what I'm going to do is I'm just going to convert that to 2.7 times 10 to the 25th. And this goes back again to understand how to put numbers into scientific notation. All right? And so notice I've done both of these problems that have these big, scary scientific notation numbers that a lot of people are scared of, and it wasn't that difficult. I actually did them relatively easily and relatively quickly. And so you can do any kind of stoichiometry problem if you just are familiar with your multiplication table, fractions, and how to work with scientific notation in your head. All right? So not too scary, ladies and gentlemen. If you did have some questions, make sure you get them down. I'll see you in tutorials. Other than that, man, let's have some fun doing some math in our heads.